Hello guys, welcome to my channel. Please, after watching this video on proof by mathematical reduction, please don't forget to subscribe. So what we want to prove is, we're given this question, proof by induction that 3 to the power of n minus 2n minus 1 is divisible by 4 for all positive values of z. So we want to prove by divisibility that 3 to the power of n minus 2n minus 1 should be divisible by 4. So what you have to do is, whenever you're asked to prove by mathematical induction, then you have to follow the following steps. So like solution, so the first step under divisibility, what you have to do is, we have to assume true for n is equal to 1, so that if that value is divisible by 4, meaning that it is also true. So assuming true for n is equal to 1. So using this expression, so we are given 3 to the power of n minus 2n minus 1, but n is equal to 1. So this is minus 2 multiplied by 1 minus 1. This is equals to 3 minus 2 minus 1, which is equals to 0. So true for n is equals to true for n is equals to 1. Since true for n is equals to 1, so the next step is to assume true for n is equals to k. So assuming true for n is equals to k, assuming true for n is equals to k, for n is equals to k. So assuming true for n is equals to k whenever n is equals to k. So we are saying 3 to the power of k minus 2n, so n is k, minus 2k minus 1 should be equal to, this expression should be divisible by 4, should be equal to 4 m say. So we have to choose the letter of your choice. Since it is divisible by 4, so we have to say 4 multiplied by certain letter, the letter you want to use. You can use A, you can use B, you can use C, any letter from the alphabet. So I choose m. So 3 to the power of k minus 2k minus 1, it should be equal to 4m say. So what we have to do here, we have to move on the third step number 3. So for step number 3, we have to assume true for n is equal to k. So assuming true for n is equal to k, n is equal to k plus 1. Assume true for n is equal to k plus 1. We want to assume true for n is equal to k plus 1. So we have 3 to the power of k plus 1 minus 2 multiplied by k plus 1 minus 1. Right. So we want to prove this one. We want to prove 3 to the power of k plus 1 minus 2 multiplied by k plus 1 minus 1. So we want to apply the laws of indices in order to simplify this one. So we are saying 3 to the power of k, 3 to the power of 1 minus 2k minus, here it becomes minus 2 minus 1. So it becomes 3 to the power of k dot 3 to the power of 1 minus 2k minus 3. But we have to factor out, here we have 3, factor out, you have to 3 to the power of k minus 2k minus 3. But remember, 3 to the power of k, we have it. Just check, assume true for n is equal to k, then make a 3 to the power of k the subgroup formula. So we are saying 3 to the power of k is equals to 4m, is equal to 4m plus 2k minus 1. So substitute this one here into here. So we are saying 3 is multiplying 4m plus 2k minus 1. This is subtracting 2k minus 3. Right. Let's now simplify this bracket. So we have 12m plus 6k minus 1 inside, then minus 2k minus 3. Right. So what we have to do is, let's now simplify the like term. So we left with 4m 6k minus 2k, which is 4k plus 4k. Then minus 1 minus 3 minus 4. Then now we have 12m plus 4k minus 4. But remember, we've assumed true for n is equals to k, where you say 3 to the power of k minus 2k minus 1 is equals to 4m say. So remember, 4 should multiply a certain expression in. That's why I said 4m say. It's like an assumption where you have to assume 4m say. Seems like 4 is multiplying a certain number. And if there is a number divided by 4, it becomes this 4m. So we are saying, let's now factor out right in this form. 4 is multiplying a certain expression. So let's factor out 4 so that it can multiply a certain expression. So 4 factor out, then you will left with 3m plus k minus 1. So if you see this expression is divisible by 4. So say which is divisible by 4. Which is divisible by 4. So since we have assumed true for n is equal to 1, which is true. Assuming true for n is equal to k, which is true. Assuming true for n is equal to k plus 1, which is also true. So since n is equal to 1 is true, n is equal to k is true, and also n is equal to k plus 1 is also true. So meaning that it is also true for all positive integral values of n. So we have to write the conclusion from these stages. So, since true for n is equals to 1, n is equals to k, n is equals to k plus 1. So therefore it is true for all positive integral values of n. Therefore it is also true for all positive integral values of z. So this is how to prove divisibility by the method of induction, by mathematical induction. So thank you guys for being together on this lesson on proof divisibility by mathematical induction. So what you have to consider, if it is divisible by 4, right? 4m say or 4a say or 4b say, the letter you want to use. So thank you guys for being together on this proof by mathematical induction, whereby we are proving by divisibility. So thank you guys for being together. Please don't forget to subscribe so that you enjoy more videos on this channel. What is the benefit of subscribing to this channel? Whenever you have subscribed or you want to subscribe, you are going to receive notification on each and every video I'm going to upload soon. So once you have subscribed and turn on your notification bell or notification button, you receive the notification in top of your phone from this channel. So thank you guys, enjoy this video. Thank you so much.